Thanks God this was not a real accident and nothing has happened to me. But the situation is absolutely real. Traffic accidents are happening every day on our roads, everywhere. And in these situations it's important to get help and first response to the location of the accident as soon and as quickly as possible. That's the reason why Europe has decided to introduce the eCall system in 2018. And Avaya has got solutions in order to make the eCall arrive in your public safety answering point as soon and as quickly and as good as possible. Let's have a look at eCall in the context of current and future developments, as I do personally believe it does not stand alone. It's a start of something new, it's a start of a new service that has the potential to change a lot on how public safety and emergency services are working on emergency calling. I would like to guide you through this next couple of minutes with giving you an overview of how Avaya are positioned in public safety and emergency services all over Europe, what our eCall standard solutions are, and beyond the standard solution, how do we interpret the eCall? eCall needs to be seen from my perspective in a SIP-centric environment, as the whole world is moving to SIP right now and the end of ISDN is near. And looking beyond the immediate requirements, we can see that eCall is involving third parties as a filter instance probably as well, or how a vision of a next generation eCall can look like. So let's get started. Avaya has always been very much committed to emergency services and public safety with deployments all over Europe. Having acquired a couple of companies over the last couple of years, former Tenovis in Germany in 2004 and Nortel in 2010, there is a lot of technology out there from different heritage. So we see a good amount of deployments with the CS1000 platform in the UK, of course, in the Nordics, in Baltic countries, Switzerland, and some other, especially in police and fire services. The Avaya Integral Enterprise platform has been deployed in some areas in emergency services in Germany. Some of those legacy platforms have been migrated to the Avaya Aura platform, which is the forward-going emergency services platform that we position in European markets. In some countries, we even find the mid-market product, IP Office, being deployed in emergency services and public safety. Let's have a look at what eCall is. eCall is a technology which clearly needs to be understood in order to find out how we can best integrate this into current or future environments. eCall in itself is an automatically triggered call directly to 112 from a car in case of an accident. For the first time, this is not just a single call, but with that call data is transmitted, the so-called minimum set of data. This is an in-band transmission inside the voice call, so that there is a modem technology being used. What is that minimum set of data? Minimum set of data, or MSD, is 140 bytes of data made available to the call taker in the public safety answering point. It's giving additional information and context to the incoming call, like the location where the incident has been happening in GPS coordinates, how the call has been activated manually by pressing the button or automatically after the deployment of the airbag, and relevant data like the vehicle identification number in order to find out what car has been involved in that crash. Let's have a look on where the call gets started. The element that is in the center of the car for the eCall is the in-vehicle system. It consists of a couple of sensors, GPS, SIM card, a processor that coordinates everything, a modem, and a connection to the hands-free communication system inside the car. So when cars crash and they are equipped with eCall technology, the trigger element probably is the deployment of the airbag. This trigger then makes the SIM card wake up and register to the best available mobile network in order to raise an emergency call to 112. Now 112 has been dialed and the call is set up through the public network, and in the end, it is sent to the most appropriate public safety answering point. As the first section of the call is the modem sequence, we will experience that within the first 6 to 10 seconds, within that modem sequence, the minimum set of data is transmitted from the car into the public safety answering point modem and made available to the PSAP call taking application. Once that's done and achieved, the call is switched over on the car side into the hands-free communication system and on the public safety answering point onto the headset of the call taking person. So we are now in the part of the voice segment of that emergency call. Let's have a look at some typical eCall deployment models that we have seen over the past couple of years. First of all, the most obvious ones are those that have been set up and built a couple of times during the early EU programs Hero 1 and Hero 2. This is a typical deployment where we have an existing PABX with a CTI connectivity into the PSAP application, where incoming calls are brought in via ISDN trunks. In this environment, we need to attach some kind of an eCall-Modem into the PABX environment to use the modem in order to decode the MSD data. Once a couple of customers have went through this first phases of Hero 1 and Hero 2, they've seen, yes, technology is working, but beside just attaching the eCall-Modem to the existing PABX, they sensed that it does make more sense to embed this more deeply into the Avaya architecture. So in that kind of architecture approach, which is typically used when environments are moved from ISDN-centric to SIP-centric, we see that we have a SIP core architecture in the public safety answering points, or even serving a couple of public safety answering points. And the application integration is done straightforward using still CTI, or probably also web services. And the eCall-Modem becomes an integral part of the SIP core architecture, which makes it very, very useful specifically in HA deployments and which can cope easily with the scaling requirements that we are probably going to see in the future. Another architectural approach is used in some countries where the organizations say, well, we do not really want to have every e-call coming into a public safety answering point immediately, but we would rather want to have a third-party organization filtering these incoming calls because we would expect that there is many false calls amongst them. In these cases, we would see the Avaya SIP core architecture with the eCall integrated into it in front of that third-party organization to be able to detect and decode the modem information, and then having the third-party organization doing their evaluation, and if necessary, forwarding the call then to the public safety answering point to make it accessible to emergency response organizations. How does this look like from an overall architecture perspective, where we have existing PABXs, existing Avaya PABXs? So for those environments that are not yet in the position to really replace their current architecture, which want to go in the traditional approach for scenario 1, we can attach the standard products that are provided by companies like Ökon or Datus in order to serve and get them ready to become eCall compliant. This is possible for all Avaya products: Communication Manager with or without Session Manager, Avaya IP Office, Avaya Integral 55 or Integral Enterprise, the former Bosch or Tenovis products, as well as Communication Server CS1000, the former Nortel products. So if this is everything that you are looking for and that you are seeking for right now in order to become compliant, this would probably be your preferred approach. But if you're looking beyond and if you're seeing eCall in the context of technology evolution, let's have a look at what we see happening around eCall right now. The first years of eCall becoming visible, so between the mid-2000 years and right now, 2016, the focus of all activity has been on standardization, has been on prototyping, has been on building pilots and thus preparing the operational phase for eCall, which is due to start late in 2017, respectively early in 2018. Now, if this has been the focus for the past, we are right at the end of that period. Let's have a look at how time is going to change when we look into the next 5 or probably 10, 12 years. So focusing on eCall first, of course, the main achievement here is to get into the operational phase for eCall in version 1, as it has been specified over the past decade. That being said, we also see that standardization for eCall version 2, or rather next generation eCall built on IMS principles, has already been started. And this is part of the iHero project that is currently dealing with the rollout of eCall in Europe, where some special attention has been put onto how do we move from version 1 to the next version of eCall. But there is also conversations about extending eCall to power two wheels, heavy good transportation, and so we expect that there is some more than just passenger cars coming to use the eCall principles in the future. Also, we see that there is conversations in the industry to retrofit existing cars, which can be done by the car manufacturer themselves, selling retrofit kits through their dealerships, or which can be done, well, by the industry, which might decide, we want to give eCall capabilities into multimedia systems, so whenever you go into your favorite electronics store in the future, you might see a nice multimedia system or navigation system for your car, which has got an eCall capability built into it. And yes, there is also conversation on getting eCall as part of a personal mobility element into smartphones directly. So this is the eCall focus on here. What's happening if we take the same period of time ahead of us, but we focus on 112 itself? I think the main focus in the future of 112 and emergency services is looking at the service provider transitioning from ISDN to SIP-based services. This is changing a lot for most of the emergency response organizations that are dealing with call taking in Europe, because most of them are connected to the service providers' networks using ISDN in these days. And between 2017, 18, 19 and 20, we hear that a lot of service providers all across Europe plan to transition to SIP-based access services and sunsetting their ISDN access services. So the natural conversation here is, we talk about SIP emergency calling, we talk about next generation 112. And with next generation 112, we also talk about the multi-channel aspect of emergency calling, which is also known under total conversation, for a full inclusion of all citizens in Europe, also those who might not have the capabilities to make a phone call talking to emergency services. And yes, there's another buzzword out there, which is the Internet of Things, and how relevant is that for the future of emergency services and 112? That being said, how does eCall adoption develop over the next couple of years? If we would only consider it for new cars coming into the European Union after 2018, it's probably true that the adoption curve is very, very slow, and many of the emergency response organizations wouldn't even have to deal with any eCall during the first couple of months after it has been activated early in 2018. But as you have heard before, there's conversations about retrofitting, there's conversations about power two wheels and heavy goods, and also personal mobility. So if we take some of these, or even any of these, into account, the slow adoption will start to become much more rapid, and you see the curve is actually going through the ceiling in here, which means for our eCall concepts and for our eCall deployments that we will require a certain element of scalability. But not only that, extending this onto 112 completely requires openness and flexibility, because these conversations on power two wheels heavy goods are basically settled upon the existence of eCall version 1, but they might come with a slight change or with a completely different service at all. And if that's the case, we would need to see another kind of decoding that location information and that other contextual information with the incoming call. And yes, in this case, flexibility and openness are really, really key. So how do we interpret eCall in SIP-centric environments? Avaya has been looking into this with a German company called Ökon. Ökon have been an expert in eCall during the past 10 years probably. They have been part of the early EU phases, Hero 1 and Hero 2. They have a lot expertise developed over the past couple of years, and they have a standard product which has been used in the early eCall phases. This eCall router basically is a Linux server. It's a box, it's an appliance if you wish, which does contain a software PBX, which does contain an ISDN line card if needed, or can connect into the PBX via an IP interface, rather SIP or H323. Internally, the communication flow is terminated by the eCall software that Ökon have developed themselves. And the data which is decoded from the MSD is provided through an application interface following an EU industry standard in a push or pull principle to be made accessible from the external world from the PSAP application. Inside the eCall software, we have the actual eCall-Modem being responsible for decoding the MSD, the eCall application that is triggering the internal workflow and that is picking up the decoded MSD. And yes, we have detected that there is a SIP client inside the eCall software, and this SIP client can now be used to make this a more versatile approach in a full Avaya environment. So now Ökon's core software does connect via SIP to Session Manager. In this case, we have a much more solid architecture approach where we avoid a PBX chain where in fact one PBX is connected to another PBX in order to make the incoming call transition through it and be decoded by the eCall software. And in order to serve the specific call flow for the eCall, we use Avaya Breeze, creating the element of workflow that we need in order to manage the data and to manage the call. The full Avaya architecture would look like this. We have the IVS originating the eCall, and when the eCall is handed over from the mobile network to the PSDN or to the SIP service provider network, the SIP service provider or the PSDN service provider, they make a decision where to route this call to based on the visibility of the eCall flag at the edge between these two networks. Now, we get the incoming call into the Avaya environment through either a SIP connection or an ISDN connection. It will be adopted in the Avaya communication layer, which mainly is Communication Manager and Session Manager. Now the eCall data itself will be managed through the integration layer, where we have Avaya Breeze in that integration layer, and with the eCall snap-in developed by Engelbart Software, we manage to send the call to the application server with the eCall software from Ökon running. Now once the MSD data is decoded, it's handed back to the integration layer, and with the integration layer we have a communication to the computer-aided dispatching environment, and we are leveraging CTI connectivity in here to bring the MSD from the communication side to the application side in the public safety answering point. So this is SIP-centric architecture. ISDN capabilities are included. All solution elements in here can be virtualized in order to accommodate a data center approach. So what you see in one picture in here can in reality be something that is geographically deployed across multiple locations with high reliability and resiliency. And we use Avaya Breeze in order to create the eCall specific workflow, which can be altered according to customers' requirement, how they actually want the operation being done. So if we look into a second very important element in eCall, it's the question how we want to integrate third-party services with eCall. Don't be wrong, there are already a couple of third-party eCall services out there, which very often call themselves eCall as well, but in fact they are not really exactly the same like the EU eCall. They are rather car manufacturer specific services associated with service calls or breakdown calls. So how would that work in an Avaya environment? Cars are in the need of raising a service call, and this call is then be raised to the call center service of this third party, and the breakdown call, minimum set of data, is transmitted. This can be a modem signal, or this could also be another transmission method like an SMS or a data service in here. The third party now is working on retrieving that data and is probably also talking to the people in the car. If they detect right now, wow, this is not just a breakdown call, but it turns out to be a real emergency call, we need 112 to treat this call, they would want to forward this call with the associate data into the 112 platform. So there are standards out there. There are European standards out there, EN 16102, that describe the third-party services eCall interface. This is not a mandatory standard for the third-party services, but if they would adopt this standard, it would be quite easy to terminate and forward the call into the PSAP environment. So leveraging a data connection, the MSD is sent over from the third-party service call center into the eCall server, leveraging the ECON API according to European standard 15722 in this case, and the call is just forwarded as a standard voice call. So from a public safety answering points perspective, it looks like just another ordinary eCall. But as I said, it's not mandatory to adhere to EN 16102. So third-party services might have other interfaces in here. And now it's the golden hour of Breeze again. So we can leverage the data connection to replicate this other interface with a custom interface on the Breeze server so that the custom set of data can be handed over here. And then we have the Engelbart API that can position this data to the call taker, still using the ECON API according to 15722 and consolidating both approaches into a single interface to the call-taking desktop environment. So what are we really up for here? The question right here, right now, to be answered until the end of 2017 is, how do we start that digital transformation journey from where we are with most public safety answering points in 112 in Europe right now into the world that is ready for adopting eCall, well, and having beside the phone, the car as another element that can issue emergency calls right now. This is what we have seen over the last couple of pictures and graphics here. This is where we bring in the eCall server as an element to decode the existing MSD. This is the requirement for now, and the driver here is clearly compliance to eCall. But what are we up for in 5 years from now? Do we really know this? Probably not. If we look back how fast technology has evolved over the past 5 to 10 years, we could expect that there is a couple of new things coming up at the horizon, and probably some things also being mandated either by legislation, which probably is not as fast, but it might be mandated by, well, the citizenship in Europe, which have a valid expectation of getting emergency services and emergency calling modernized. And drivers in here can be omnichannel, drivers in here also can be the Internet of Things. So how does that look like? We have moved our existing world into an eCall capable world, and if we want to make this omnichannel capable, yes, there is a need to deploy a multi-channel or an omnichannel real-time communication engine, which is ready to work with current eCall, but when looking into 2020, 2021, it would also probably be able to work with next generation eCall coming up here right now. So in the same time, we have the transition from PSTN, ISDN networks to SIP service provider networks, which might be the dominant public networks in the next 5 years on the European continent here and in the UK as well. So if we see this, we also see that the internet is coming closer and closer. So everything that we associate with the Internet of Things, sensors, wearables, and probably other things, are seeking for an entry point into public safety answering points, communication environments, and applications as well. And it's the Avaya Breeze platform here again, which opens up that additional communication path in kind of a machine-to-machine communication or in a machine-to-human communication. And the effect of that integration will be that the integration layer is becoming more and more important, and probably with the integration layer we see the rise of another layer, which is the analytics layer, in order to prevent flooding and overwhelming work for the call-taking personnel in the public safety answering points. Technology does change, and it does change fast. And we must move forward here, and we must become more flexible in order to be able to comply with future requirements. Moving to SIP, leveraging voice over IP and multi-channel prepares the path to the Internet of Things already now. And these new technologies have to be integrated quickly as they become relevant to public safety and emergency services. So new services have to be created with much more agility than in the past years. eCall, in fact, from my personal interpretation, is the first IoT service which is entering the PSAP. It is not a phone service, as many people think it is, because it is using the phone service. But as we are dealing with sensors, as we are dealing with automation, as we are dealing with additional context to the call, it is more of an IoT service in disguise of a phone service. It took 15 years from concept to introduction, and I believe that these timelines will not be acceptable anymore in the future in order to adopt new technologies fast, in order to make Europe more safe for the citizens of Europe. So if you're interested, there's quite a new white paper out there available on the European Emergency Number Association's webpage, which talks about the Internet of Things, public safety and digital transformation, and how IoT and emergency services are working together. So feel free to download it and have good reading. So looking beyond the obvious, we have already touched on this, eCall involving third-party services as a filtering instance. How does that work, applying a filtering instance before involving the PSAP? The business considerations are quite relevant from many organizations' perspective, although not every country has chosen the same approach. It is to prevent many false eCalls hitting the PSAP immediately. It is about identifying, is this an emergency call or rather a non-emergency or roadside assistance call? And it can be centralized for a whole region or for a whole country as a single eCall center covering every incoming eCall for that geographic area. Of course, the challenge with this approach is there may be an additional time delay in case of there's a real urgency in the call, as it needs to be handled by 112 emergency services. So how does that work? The eCall is coming in through the ISDN and it's hitting the Avaya eCall platform where it is picked up. The MSD is extracted, and the first element that we are leveraging in here to make a decision is the vehicle identification number. Based on the vehicle identification number, a decision is being made which assistance service, A, B, or C, is the most appropriate one to deal with that call. So we are looking up in a central database what service is the right one to deal with that specific car from that specific manufacturer. And in our case, it's assistance service B. So the call is routed to assistance service B. And now we have the MSD presented through a web services interface. And assistance B is looking into the MSD details and starts the qualification. Is this rather roadside assistance or is this a true emergency call? And in case it is a true emergency call, well, then the next step is working. They are again leveraging the web service, and through a command pushed into the web service, the next element of the MSD is evaluated, which is the location element. Now, knowing that this is an emergency call, we need to find out which is the most appropriate public safety answering point and which region is responsible to take this emergency call. Looking into the location data, We match the location against the regional responsibilities of the different public safety answering points. And in this example here, we find out it's region 3 that needs to take this emergency call. So we are forwarding the emergency call to the public safety answering point in region 3. And again, leveraging the web services interface, the MSD is pulled and all the necessary information can be evaluated by the PSAP so that they can make a good routing decision, a good mission management, and they can send the ambulance car in the fastest possible way to help the people in the cars involved in the accidents. I think it's important to mention that in this example, the only thing that Avaya really provides is the centralized eCall platform. All assistance services, as well as all PSAP services, they do not necessarily be equipped with Avaya equipment as well or Avaya communication platforms as well. They can have whatever they want to have. What they need to do is they need to connect to the web services interface and they need to find a way how to manage the incoming call and how to retrieve the MSD through the web services and get them presented in their call taking applications or in their business applications in case of the assistance services. Another perspective is, well, how do we look into next generation 112 and how do we leverage things that we would want to look at when we talk about the Internet of Things? So next generation eCall or eCall version 2 will be built leveraging IMS principles and full SIP transport end-to-end. There are already on the IETF web pages the first drafts out there visible for you, and the core changes to current eCall definitions is that we will have more data available in the MSD, plus more additional data available, optional data, to be populated properly by car manufacturers or even other organizations. A key change in here is as well that it's being to be more than just a voice call, so it needs to handle video as well as text. And the PSAP can have access to some components in the vehicle. For instance, onboard cameras. So many cars are equipped with onboard cameras right now. And if the PSAP can have access to these onboard cameras, they can have a look if they see something that might be relevant to mission management even before or at the time when the on-site intervention team is approaching the accident scene. The PSAP can also request the vehicle to take some actions like sounding the horn, disabling the ignition, locking or unlocking doors. And we will no longer have the challenge of the voice call being muted during the transmission of the MSD, as it will all be IP based in this context. So let's have a look how a vision of a next generation eCall service can look like. Let's assume the following. There are new cars out there, and specifically this car has been rented at some airport. And 3 people are going to sit into this car. 3 seats are occupied, which is registered by the car. The car's onboard system, the car's onboard unit computer, does also recognize that all of these 3 people are having smart devices with them via Bluetooth. So it can offer to connect the smart devices for safety and security purposes onto the onboard unit. And once that's done, we might also discover that behind these 3 smart devices, in 2 instances, 2 of these persons do have a wearable, so kind of a smartwatch or a fitness tracker, which is able to detect heartbeat rates. So that data now is stored in the database, and we hope that nothing really is happening as the journey continues. If there's an accident right now, of course, we are going to initiate an eCall. And like in current eCall version, of course, the location will be transmitted, the VIN will be transmitted, propulsion type will be transmitted, all the regular stuff with eCall version 1. But beyond that, we might also see that the additional information that we have created when the people enter the car can be made available as well to the public safety answering point, saying, inside the car, 3 seats are occupied. I have 3 smart devices which are connected and accessible from the outside world through a URL. And probably we have 2 wearables paired to these smart devices, Well, we could probably monitor the heartbeat rate. So what does this do to a call-taking environment and to a mission management from a public safety answering points perspective? If you have a mass accident happening on one of the heavy traffic roads in Europe on a foggy morning, where probably 30, 40 cars are bumping into each other, which are the red cars in here, and there is other cars, the yellow cars, stopping behind the accident scene, and the blue cars on the parallel lane also stopping, and all of them are raising calls to 112. eCalls, automated eCalls, the red ones, coming in first, populating the PSAP queue quite heavily, and the blue calls manually originated by pushing either the eCall button in the car or manual dialing 112 will sit in that queue as well. So just imagine, how would you deal with call taking if you had real-time access to that additional data of the calls in your queue? If you would know what these calls are about. If you know that an e-call handling may probably take you twice or 3 times as much because there's no one in the car that you can talk to, maybe they have escaped already from the car, so you're blocking a precious call-taking resource for a minute without any effect. You would rather want to talk to the people in the yellow cars in here, which can give you much more information. So there are strategies to be developed on the call-taking side. And how probably this might affect the mission management if you knew that there is a person in this specific car that has been turned over that shows critical health conditions based on heartbeat rate. Well, if you arrive on scene and you knew that there is one person in severe danger, you could go there immediately without doing the traditional triage approach, going from car to car. And how would you deal with the medical treatment if you would be aware of additional personal data transmitted with the call about medicaments being taken or diseases people have when they're somehow involved in the scene of the accident and you would need to take them to hospital? The hospital could be made aware of these medical conditions upfront and could treat them much easier and much better. So all of this is a view into the future. It is a vision, but I think it's something we can start thinking about. So how does Avaya deal with this? We have the Avaya Aura core applications that make the different channels available, accessible for citizens that call into public safety environments. And we have a very performing and easy to manage middleware layer, which we call Avaya Breeze. And now if we have this middleware layer in here, we can start building so-called snap-ins as we would need them. And the first snap-in that we will need in this case, of course, in order to provide compliance to EU eCall environments, including third-party services eCall, is the eCall snap-in that we have available right now. But beyond that, there is more snap-ins that we can bring into this environment that can deal with locating services and giving access to additional context, additional data with the incoming services, like next generation 112 calling through SIP emergency calling in general, like providing Avaya iLocate multimedia services and geolocation services which work on an SMS and data services base. We could even easily, and we have done that already, integrate Google's Android advanced mobile location services, which also can build on SMS or data services. And we have already integrated the popular RealRider services from the UK, which is available for motorcyclists, referring to mobile location of an accident via an SMS service as well in here. So all of these are available, and they all build on the same principles of Avaya Breeze as a very flexible middleware layer. And this sits on top of Avaya Aura as a highly scalable, highly functional, multi-channel and multi-purpose services environment for public safety and emergency services. I hope this information was useful to you. Please don't hesitate, reach out to Avaya, get in touch with your personal representative and start your personal eCall conversation.